Okay, think about this for a second. What if your phone could get way smarter, more personalized, more helpful, but without ever needing to send your private messages or your photos to some company's server? Sounds kind of like magic, right? Well, today we're going to dig into the groundbreaking paper that actually made this a reality. This is the story of what we now call federated learning.
So it really all boils down to a question I bet you've asked yourself. You know, when your phone's keyboard suggests the perfect next word you were about to type, how does it do that? Or when a photo app suggests just the right edit? The real question, the big one, is how can these apps get so smart without, spying on us and sucking up all our private data?
And right there, that's the fundamental problem, the big trade-off in modern AI. Of course we want these amazing smart features, but the old way of doing things meant we had to give up our privacy. It meant our most sensitive data, our private messages, our photos, had to be shipped off to a central server somewhere. And that's a huge privacy risk, just waiting to be exploited.
So to really get why this new idea is such a game changer, we first have to talk about the problem it solved. Let's take a quick look at how things used to be done, the old way of training AI.
Yeah, the old approach was, it was brutally simple. The strategy was basically collect everything. To train one of these huge, powerful AI models, companies would just hoover up enormous amounts of our data, all of it, and stick it in a giant data center. Sure, it gave them the raw material they needed, but it also created this massive, tempting target for hackers, a real treasure trove of private info.
And the researchers in this paper make a really crucial point. Even when companies tried to anonymize the data, it just wasn't enough. It's not a silver bullet. Turns out, if you combine that anonymous data with other public information, you can often figure out exactly who is who. The risk was still there, plain as day. Something had to change. We needed a completely new way of thinking.
And that brings us to the big idea, the paradigm shift. It all starts with a really simple, but honestly, a profound question. What if you could train a powerful AI model without ever actually seeing the raw data it's learning from?
That question, that's the whole idea behind federated learning. It completely flips the script. It's a decentralized approach. So instead of bringing all of our data to one central model, we bring the model to our data. The learning happens right there on your phone, in your hands. And the most important part, your personal information never, ever leaves your device. It stays with you.
Okay, so how does this actually work in practice? Well, think of it like a loop that just keeps going. First, a central server sends out a generic starter model to tons of devices, maybe millions of them. Step 2, your phone takes that model and uses your own local data, say the way you type, to improve it, just a little bit. Now here's the really clever part, the magic. Your phone doesn't send your typing data back to the server, no way. It only sends back a tiny anonymous summary of the changes it made, just the updates. Finally, the server takes all these small updates from everyone, averages them together, and creates a new, much smarter, shared model. Then that new model gets sent out, and the whole process starts over, getting better and better with every cycle.
All right, that all sounds fantastic in theory, right? But to actually make it work in the real world on millions of phones, that took a special kind of secret sauce, an algorithm they called federated averaging.
You see, the biggest challenge wasn't actually the computing power on our phones. I mean, these things are pocket supercomputers already. The real problem, the massive bottleneck, was communication. Just think about it for a second. Trying to send huge chunks of data over a mobile network, it's slow, it can cost you money, and your connection can drop at any moment. So any system that needed constant heavy data transfer it was never going to work. It was a total non-starter.
And this is where the genius of their FedAv algorithm really shines. You see, the simple or naive way to do this, which the paper calls FedSGD, would be for each phone to do one tiny calculation and immediately send it back to the server. But that would mean thousands and thousands of rounds of communication. It's just not practical. So the smart way, FedAv, does something different. It lets each device do more work on its own. It crunches through the local data multiple times to come up with a really powerful, high-quality update. Then, and only then, does it send that one single update back. So a little more work on the device saves a ton of communication.
There's a great analogy for this. Think of the AI model as a secret recipe. Now, instead of thousands of cooks sending all their secret family ingredients to one central kitchen, which would be a total privacy nightmare, right? They each take the recipe and tweak it in their own kitchen. Then, all they send back are their suggested changes. Things like, hey, try adding a pinch more of this, or I think it tastes better if you bake it for 2 fewer minutes. The main chef can then take all that feedback and perfect the one master recipe for everybody, without ever seeing their secret ingredients.
Okay,
So it's a clever idea, a great analogy, but does it actually work? I mean, in the real world? Well, the proof, as they say, is in the pudding. Or, in this case, in the numbers.
Okay, now these two charts are really cool. The one on the left shows that, yeah, the algorithm works perfectly on what we call IID data. Just think of that as perfect, clean, evenly distributed data, the kind you'd find in a lab. But the chart on the right, that's the one that's truly impressive. It shows that the algorithm also works incredibly well on non-IID data. And that is the messy, unbalanced, totally unique data that each of us has on our own phones. In other words, it works where it actually matters, out in the real world.
And if there's just one number you take away from all this, let it be this one. For one of their tests, they trained a language model using the complete works of Shakespeare, where each character's speaking part acted like a different user's data, super realistic, messy data. And their method, federated averaging, hit the goal with get this, a 95 times reduction in the amount of communication needed. That isn't just a small improvement. That is a massive, monumental leap forward.
Let's look at another one, this time for image recognition. The old baseline method took 626 rounds of back-and-forth communication to reach 99% accuracy, okay? 626. But FedAv, their smart method, it got to the exact same place in just 18 rounds. 18! That's almost a 35 times speed up. The evidence here is just, it's undeniable.
So let's zoom out. We've seen the tech. We've seen the numbers. What does this all mean for us, for the future of AI? Why does this stuff matter so much?
All right, what are the key things to remember? Number one, and this is the big one, our data stays private. It stays on our device, period. This means we can have smarter apps without giving up our privacy. Number two, the real breakthrough here was solving that communication problem. That was the wall everyone was hitting. And finally, this was more than just a clever algorithm. It was a fundamental shift in how we think about AI. It proved you don't need direct access to raw data to train a great model.
Look, this breakthrough just blew the doors open. It fundamentally severed the link that said smarter AI requires more of your data. And that forces us to ask a really exciting question. Now that we know AI can learn without actually seeing our private information, what else is possible? What comes next?